Hi, welcome to another Math Concepts video brought to you by the Math A Learning Team. Today we're going to be doing a quick review of solving right triangles using trigonometry, your good old SOHCAHTOA, sine, cosine, and tangent. We're going to be specific. We're going to be finding only a length or an angle to the nearest tenth. Notice that uppercase letters denote angles, and the corresponding lowercase letter will denote sides. For this first problem, notice that we already have the angles labeled. Opposite of angle A is side A. The length of side A in this case is 8. And we want to know the length of side B. That is our unknown. And we are also given the measure of angle B is 24 degrees. Okay, that degree is important. You need to make sure your calculator is in degree mode. So always in reference to the information you're given. In this case, angle B, we have the side opposite of it that we want to know, and we have the side adjacent to it. Opposite over adjacent is your tangent ratio. So we will go ahead and set up our tangent ratio. That would be the tangent of the angle 24 degrees is equal to the opposite length. Again, opposite is directly across from. There's our variable b over the adjacent, or the next to length, 8. Okay. Notice now we have a proportion. We can go ahead and cross multiply. Okay, so you're going to go ahead and take b times 1, which is b, and then you will multiply the tangent of 24 degrees times 8. There's your heart, in case you've forgotten how much you love math. So we take the tangent of 24 degrees times 8. This will be on your calculator. If you go ahead and take the tangent of 24 times 8 and round to the nearest tenth, you should have an answer of 3.6. Okay, so that's just a quick review of solving for a side length. Very similar. Let's take a look at another problem here. Okay, we have our triangle again with uppercase letters, angles A, B, and C. In this case, we know the length of the side that is opposite of B is 16. That's a given. The length of the hypotenuse, which is across from the right angle, is 25. And we want to find the measure of angle A to the nearest tenth. Okay, so that is our unknown. Now you have to look at everything from the perspective of that angle. From the perspective of that angle, we don't know the opposite or across from length, but we have the adjacent length and we have the hypotenuse. Okay, adjacent over hypotenuse is your cosine ratio. So we would work with the cosine of angle A, there's our variable, is equal to the adjacent leg, 16, over the hypotenuse, 25. Adjacent again is next to, the hypotenuse is always opposite the right angle. Now, again, if you haven't done this in a while, when you're looking for angles on trig, you're going to be using the inverse buttons on your calculator. Okay, so if you look above cosine, using the second button on your calculator, you're going to see cosine inverse. So you want to press second cosine. I'll go ahead and write out the button that you will push here, of 16 over 25, and then press enter. Okay, so writing that out, really you're working with the cosine inverse of the ratio, 16 over 25, and then press enter. To the nearest tenth, the measure of angle A should be 50.2 degrees. We know to use the cosine because in relation to the acute angle A, we had an adjacent length and the hypotenuse. Could use the inverse functions, but really no need for that. You will also be able to apply using trig for some word problems. Just a brief review here. There's basically two types of word problems you use in trigonometry. We have what's called angle of elevation problems and angle of depression problems. Angle of elevation, you just got to always remember and say to yourself, angles of elevation are formed horizontal and up. You'll be working with an application of a right angle. Horizontal and up. For the example, if you were standing away from a building and looking at the top of the building, here you are, happy you. Okay, you're always forming an angle with the horizontal and up. So angle of elevation, always think to yourself, out and up. It is never, ever the angle that is formed with the vertical apart. Okay, it's never this angle up here. The opposing type is your angle of depression. Angle of depression, if you were at the top of this building, you want to think out and down. Out and down. Okay, so here you are at the top of this building. The angle of depression is formed by going out and looking down. I'm using theta to denote the angle of depression. So angle of depression, always think out and down. Okay, a very common mistake would be to label this as the angle of depression, but notice that that angle is formed with a vertical line. It's always an angle that's formed with a horizontal line and down at the object. Or angle of elevation is always formed with a horizontal line and up to the top of the object. There are some words that are synonymous: angle of elevation, angle of climb, angle of depression, angle of descent. These are all applications that you will solve using right triangle trigonometry.